All right, so one of the types of problems is going to use a thrown object equation. And a thrown object is going to have some kind of initial velocity, which is here, some kind of starting height, which is here, and then the negative 16, that's going to be the same for all of them, more than likely. Okay, and so if you're looking to take an equation, this equation already has interpreted the information from the problem. So here's your initial velocity, here's your initial height. Those have already been placed inside the function. And so all you need to do is identify several things. The maximum height, at what time the ball reaches the maximum height, and then at what time the ball is going to hit the ground. Right? So in order to answer these, the first thing that you can do is the maximum. Anytime you see maximum, you're thinking vertex. So we are going to find the x-coordinate of the vertex here. So our vertex, or our variable is t for time. So to find the x-coordinate of that, t is equal to negative b over 2 times a. And so if you use your calculation, this is the x-coordinate for time. Or in this case, it's the t value, sorry. And when you calculate your t, the negatives cancel. And if you take 80 divided by 32, you get 2.5. Okay, so what you see right here is the x-coordinate of your vertex is 2.5. That's the time that it takes for the ball to reach its maximum height. So that is the first answer. Okay, at 2.5 seconds, the ball will reach its maximum height. To identify what that maximum height is, we're going to take our function right here, and we're going to evaluate the function at that time. So if we take h of 2.5 and solve, so negative 16 t squared plus 80t plus 40, I'm going to use the with key, vertical bar, t is equal to, and I'm just going to plug in my 5/2. Okay, I do want my answer in decimal here. And this is going to give me my maximum height. When I hit enter, I get 140. Okay, so the maximum height of this ball is going to be 140 feet. And then finally, it asks, when does this ball hit the ground? Well, the ball's going to hit the ground when the height is what? 0. So if I know this is my function for height, what I can do to find when it hits the ground is I can set that function equal to 0 and solve. Okay, again, you can either enter it directly, or you can, if you had put this into the Y editor, you can do it that way as well. So I'm going to go ahead and just use the solve feature here. So I'm going to go in front of my function, click solve, set this equal to 0. So 0 equals, I write my whole equation, which I've already written. So I'm just going to move to the end and identify the solution for t. I do want my answer to be in decimal form. Since I haven't entered a decimal in my entry, I'm going to hit the diamond button so my answer displays as a decimal. And that gives me 2 possible values, right? So 5.46 approximately and negative 0.46. Okay. Are we going back in time on this problem? No. Okay. But the one value that we have here is 5.46. So that is the amount of time it would take before the ball hits the ground.